right, so before we can talk about an isosceles trapezoid, we have to talk about a general trapezoid. So, if I'm talking just a general trapezoid, so it's that one on the left side. All right. Celeste, can you erase the board for me? Thank you. So, biggest thing with a trapezoid is it has at least one pair of opposite sides that are parallel. Those are known as their bases. So, it's considered a trapezoid if it has one pair of opposite sides that are parallel, or at least one pair. So, in terms of a trapezoid, where does it kind of fall in the hierarchy? Would it be kind of below? Would it be a child of the parallelogram, or would it father the parallelogram? It would father it. All right. So a trapezoid in the hierarchy is actually the parent of the parallelogram, because since a trapezoid has to have at least one pair of opposite angles, not opposite, one pair of opposite sides. Parallelogram has two. And that's at least one pair, technically. So the trapezoid fathered the parallelogram. Now, other features of the trapezoid. Just a general one, not the isosceles. All right. The leg angles are supplementary. And the median is equal to the first base plus the second base divided by 2. All right. So if we look up here at our picture. All right, my general one is the top one. So right here are our parallel bases. So let's call this one B1. Let's call this one B2. Your leg angles are right here. Now, if it's a general trapezoid, it does not guarantee a congruent angle. All right. So these are leg angles, and these are leg angles. Basically, the legs are the sides that are not parallel to each other. So this set of angles will be supplementary. This set of angles will be supplementary. And then what they're talking about the median. So a median is just if you were to take the height. All right. So if you were to take the height of the trapezoid, this would be your median. And that's how you would do the first base plus the second base's length divided by 2. All right. So let's take a look at this problem. So it says to find the value of x. So we're finding that value of x. Oops. What the? I don't know what that just did. Okay. So we're finding the value of x. Now, we're talking about, it's a little hard to see, but this is 12x plus 3, 13x plus 2. All right, we're looking at these two angles. So what's the relationship between the two? They're supplementary. These are two leg angles because our parallel bases are right here. So that means this side has to be a leg. And if the angles that form, or the angles that are formed by that leg are the leg angles. So in other words, one of their rays that form them is the leg itself. So since they're supplementary, how would I set my equation? 12x plus 3 plus 13x plus 2 is equal to 180. So guys, with setting up your equations, you're either going to, more often than not, you're either going to set it equal to 180 or you're going to set them equal to each other. You set them equal to 180 if they're what? Supplementary. You set them equal to each other if they're what? Congruent. All right, so that's the difference. So if I combine some like terms, I get 25x plus 5 is equal to 180. Subtract the 5, I get 25x is equal to 175. So what's x equal if I divide both sides by 25? It'll be 7. So x is equal to 7 here. Now, that's a general trapezoid. Isosceles trapezoid. So think about an isosceles triangle. What's true about an isosceles triangle? Jason. So an isosceles triangle, you have two congruent sides. A trapezoid isosceles is the exact same thing. So an isosceles trapezoid, two sides are congruent. All right. And it's typically the legs. All right. So if you're wanting to know what an isosceles trapezoid is, think about an isosceles triangle. Essentially means the same thing. Two sides are congruent. All right. In this case, the legs are congruent. So the ones that are not parallel to each other are congruent. Now, properties is the same as a trapezoid. So if I wanted to do in the hierarchy, a general trapezoid would come first, then isosceles trapezoid, and a parallelogram is technically an isosceles trapezoid because the opposite sides are congruent. All right, but I'm not going to add isosceles trapezoid in the hierarchy. Just know that a trapezoid becomes a parallelogram. And the base angles are congruent. And the diagonals are congruent. All right. So if I go up here to my isosceles trapezoid, they already marked the parallel. They already marked the congruent legs. Now, what they mean by base angles, they're talking about the angles that are connected to the same parallel line. All right, so these two angles would be congruent. Those are two of my base angles. And these two angles would be congruent. Those are my other two base angles. So notice how they are, both of those angles are formed by the same parallel line or the same base. And then the last thing is that these diagonals are congruent. So the diagonals themselves are congruent. However, they do not bisect each other. So unlike a parallelogram where they cut them in half, trapezoid diagonals do not bisect. All right. So, but since they're congruent, wherever they do intersect, the two individual pieces, the corresponding pieces, are congruent. So short piece to short piece is congruent, long piece and long piece are congruent of the diagonals. But again, they do not bisect. It's not like that of a parallelogram. They don't bisect till they become a parallelogram. All right. So let's do a problem here. Trap is an isosceles trapezoid. If PR is 3x minus 7 and TA is equal to 20, what's the value of x? So PR, so this whole length right here is 3x minus 7. And TA, or this whole length right here, is 20. So what's true about an isosceles trapezoid? With its diagonals? They're congruent. So how would I set my equation? Right, 3x minus 7 is equal to 20. That's just a nice little two-step equation. So add the 7. 3x is equal to 27. Divide both sides by 3. X is equal to 9. Now, the last quadrilateral that we're going to talk about is a kite. Now, when we talk about a kite, we're going to discuss kind of where it falls in our hierarchy as well. All right. So for a kite, it literally is what you think it is. It literally looks like, the stereotypical kite, like, fly a kite. All right. So it literally looks like if you went to go fly a kite, like what a stereotypical kite would look like. So with a kite, it has two pairs of consecutive sides that are congruent. Now, what does consecutive mean? Well, that's true, but non-geometry. Back to back, right. So adjacent, meaning they connect. So when you think of consecutive, you could think of it as, one after the other. All right. So like 1, 2, 3, 4, that's consecutive. It's one number after the other. They connect. And those sides are the congruent ones. Whereas the opposite sides, what we're used to, are not congruent. But the opposite sides are parallel. Okay. Then diagonals. The diagonals are perpendicular to each other. So just like a rhombus, they come together, form a right angle. Only one pair of opposite angles are congruent. And one diagonal bisects opposite angles and the other diagonal. So it doesn't cut both diagonals in half. It only cuts one of them in half and only bisects two of the angles. So let's look at our picture up top. So with the kite, notice how these two sides are congruent and they're consecutive because they come together at the same point. These two sides are also congruent because they come together at the same point. Now, then, the diagonals. All right. The diagonals are perpendicular, so they come together at a right angle. The diagonal, one of the diagonals bisects the other. It's typically whichever diagonal does not have the congruent angles or does not connect the two congruent angles, that's the one that bisects. So the congruent angles would technically be here. Those are your two congruent angles, which means this is the diagonal that gets bisected. All right. And then it also bisects its angles. So it says it bisects its one diagonal bisects its opposite angles, and it bisects the other diagonal. So these two baby angles are congruent, and these two baby angles are congruent. But they're not congruent to each other. That's why I marked one with 3, one with 2. Yes. Oh, you're stretching. Okay. All right. So let's look here. So it said to find the it said find the angles of measures 1, 2, and 3. So it's kind of hard to tell where they're at, but this is angle 1, 2, and this is angle 3. All right. Now, which one do you think will be the easiest to start at? 3. No. It's definitely 1 because 1 we should already know what that angle to measure is. It's 90 degrees. Why? The diagonals are perpendicular. Now, what would then be the next easiest angle to find? 2, because now we have a 90-degree angle, but we also have another angle labeled here as 27. And we have a triangle. So how do I find it? Add 90 and 27 together and do what? Subtract from 180. Oops, I totally wrote this wrong. Angle 1 is equal to 90 degrees. So to find angle 2, I would subtract 180 from 27 and 90. So what would that give me for angle 2? 63 degrees. Now, angle 3 we can find in a similar way because what's true about this angle right here, this big angle? Well, what happens with that diagonal to that big angle? So this diagonal, the long one, what does it do to that red angle? It cuts it in half. It bisects it. So wouldn't this also be 27? So we could find it the same way. 90 degrees, subtract it from 180 and 27, so that would be 63. The other way you could have thought about it is these are my two congruent angles here. So this big angle is congruent and this big angle is congruent. So 2 and 3 would have technically been congruent triangles anyway. All right. Remember, you got to finagle to get what you want. Okay. All right. Last one. We're going to solve for x and y. So let's solve for x first. So it comes from these two angles. What's true about those two angles? They're congruent. All right. Yeah. Typically the angles between typically the how you figure out which one are the congruent angles, because only one set of opposite angles are congruent, it's basically the angles that come from the two non-congruent sides. So do you see how these two sides here are not congruent and these two sides are not congruent?
Yeah.
So like this one has 1 dash, this one has 2. So the angles that are congruent are the ones that are formed by the non-congruent sides. All right. So if these two angles are congruent, how would I set my equation? Set them equal to each other. So 4x plus 13 is equal to 5x minus 15. So I'm going to subtract the 4x to both sides, and I'm going to go ahead and add the 15 to both sides just to save me some time. That goes away. That goes away. I get x is equal to 28. So that's what x is equal to. Now, these two angles. All right. What's kind of the relationship there? Yeah, they are alternate interior. All right. But we cannot assume that they're congruent because technically, since it bisects each other, but these two angles are not congruent. So we kind of got to do a little bit extra. All right. What's one way that I could find angle y, though? So not y minus 9, just y. What's true about these two angles? They're supplementary. All right. So if they're supplementary, couldn't I plug 28 back into my 4x, get that angle measure, make sure we add y to it, or 2y, because remember these bisect each other, so this is also y. Is that equal to 180?
Yes.
I could. So if I plug in 28 in for x, what's 4 times 28? And then add 13. Right. So that'll be 125. So this is 125 plus 2y equal to 180. So subtract the 125. What does that give me? 55 divided by 2. Y is equal to 55 and a half. Now, if we wanted to... Yeah, we'll just leave it at that. All right. Any questions on any of this? All right. So, you guys feel pretty comfortable with the properties? All right. So, now let's talk about where the kite would fall in the hierarchy. So, in order for it to be considered in the trapezoid family, or a child of the trapezoid, it has to have at least one pair of parallel sides. Is that true? No. All right. So, a kite is actually a sibling of the trapezoid. So, quadrilateral is the big daddy.
Whoa.
All right. So it breaks down to the trapezoid and then the kite. The kite is kind of like the estranged aunt or uncle. All right. It's just kind of by itself. It doesn't have any children. All right. Or they're like that cool aunt or uncle that just have a kiss and just spends their money traveling everywhere. All right. That's the kite. Trapezoid settled down, had a family. All right. So I would jot this down in your journal as well, because in terms of memorizing the different properties, if you know the properties of a square, you know pretty much all of them up to a quadrilateral. Parallelogram, if you know the properties of a parallelogram, you pretty much have almost all the properties of a rhombus, a rectangle, and a square. All right. Only difference between a parallelogram and a rhombus has two congruent sides. Not two congruent sides. Rhombus has all four sides congruent. Difference between a parallelogram and a rectangle is 90-degree angles. All right. So this hierarchy is really, really important. I would. So yeah, I would jot this down in your notebook because it is important.
Could you email me the notes?
I'll post it on campus. Yeah. It should already be posted from yesterday, though. It should be. It's on the note page. Not the journal page, the notes page. Because I don't post it on the journal page until it's completed. All right. Now, let's go into our next section, which is proof. So now that we know the properties of quadrilaterals, let's start proving them. But before we do that, we're going to just review our properties and make sure we're pretty solid on that. So take out your packet and go to page 5. So here's what I want you guys to do, because we already talked about this. What I want you to do is that in your group, all right, there's 3 people. One of you gets assigned one shape. So a parallelogram, a rectangle, or a rhombus. All of you are doing a square. All right? So everyone does a square. What I want you guys to do is go through for each of your shapes and compare it to what we said in our journal entries. Go through and check off which key features it has. All right? So for example, if it has 4 sides that are congruent for a square, that's true. So you would put a check there or an X or whatever. All right? If it doesn't have that property, leave it blank. And I want you to do it for both these 2 charts. Now, once you get it done for your one shape, compare with your groups. All right? So I'm going to give you guys about, 5. So I'm going to give you guys, let's start with 7 minutes, see where we're at. All right? So, again, we've already talked about all of these properties. There should be nothing new.
Yes, I'll take.
So, one of you needs to do the parallelogram, one of you needs to do the rhombus, one of you needs to do the rectangle, and you're all doing the square. You can do the square together if you want. So decide amongst yourselves now.
Right. It's not all of us. Harry.
So you're just checking off what properties that each shape has. And remember, some of those will be blank for some shapes. But it doesn't have that property. So for example, a parallelogram does not have all sides that are congruent. You're going to check that. So everyone should be doing at least one shape on their own, and then the 4th shape you guys can do together.
I do not.
What was this one? That's
This rectangle.
We
did rhombus.
And I'm talking about a generic version of it. All right, don't overthink it. Because they're all 90, right? I'm already done. So guys, once your group finishes, make sure you compare answers and make sure you jot down what they got. So once you finish talking about the sides and the angle, then try the diagonals with your same shape. Yeah, the diagonals. So guys, you pretty much have the answers in that journal. Use that girl to your advantage.
Bisect opposite angles. Parallelogram doesn't bisect opposite angles.
Yeah.
What good? Isn't it just like all of them?
Yeah.
Wait, so all of them are just the same except square?
Perpendicular means they cross at 90 degrees.
Oh, they just
They just bisect. They just bisect each other.
Can I see yours?
Wait.
Oh, it's a work project.
So can't we just check all of them?
I think so.
For square, yeah, it's like that.
Everybody else with your guns?
Both sides.
I actually need to answer.
First, me and action.
Everything besides the all sides.
And I'm like, oh shoot.
You're done. You're done, bro. She said I was right. Yeah. Said it was right. No, she did. This work does not lie.
She's right.
I'm just figuring out how to work. So y'all can hear it. Make sure you guys checked off. Let's do it. Got about 2 more minutes. Make sure you do both tables.
Oh. I told you I'm hard.
So now y'all compare notes.
Okay. For square, I did all this.
They're just not
Are we done?
rectangle.
We done.
Yeah. That's what I think.
The parallelogram is almost congruent, right? Yeah. Yeah. That's why I don't. I have to. On 25. Yeah. But also, because I say that
Yeah, I kind of have.
high school.
All right, guys. So time's up. So let's do this. Raise your hand if you are the one doing parallelogram. So if you had parallelogram, raise your hand. I should see at least one person from every group. All right, so Harris, what's true about the sides of a parallelogram? Just the sides, not the angles. Well, what'd you check off? So there's 4 sides. Are they parallel? Yes. All my parallelograms, are they congruent if they're opposites? Yes. Are all sides congruent? No, not for a generic. Are opposite angles congruent? Yes. Are all angles congruent? No. All right, raise your hand if you did my rectangle. So my rectangle people. Everyone. At least one person from each group should have their hand raised. All right, rectangle people. Obviously, it's a quadrilateral that has 4 sides, but are the opposite sides parallel? Yes or no? Yes. Are the opposite sides congruent? Yes. Are all sides congruent? No. Not generic rectangle. Are opposite angles congruent? Yes. Are all angles congruent? Yes, because every angle is what? 90 degrees. So yeah, the angles are congruent. All right, my rhombus people, that should be the last person in each group. All right. So my rhombus people, obviously it has 4 sides. Are the opposite sides parallel? Yes. Are the opposite sides congruent? Yeah. Are all sides congruent? Yes. For a rhombus, yes. All right. Are the opposite angles congruent? Yes. Are all angles congruent? No. So, guys, shh. What separates a rhombus and a rectangle is right here. A rhombus has all sides that are congruent. A rectangle has all angles that are congruent. All right, that's what separates them. And then a square, like I said, it's the love child of the rhombus and the rectangle, so everything's checked off. All right. Now, diagonals. All right, parallelograms again. So, do they bisect each other? So, do the diagonals cut each other in half? Yes. Are they congruent? No, not for a generic parallelogram. Do they bisect opposite angles? No. Are they perpendicular? So do they cross? Where they cross, do they form a perpendicular angle? No. So the only thing a parallelogram diagonals do is they bisect each other. All right. Rectangle. Do the rectangles bisect each other? Yes. Because remember, they have all the properties of a parallelogram. Are they congruent? Yes. Do they bisect opposite angles? No. Are they perpendicular? No. Rhombus, do they bisect each other? Yes. Are they congruent to each other? No. Do they bisect opposite angles? Yes. Are they perpendicular? Yes. And then a square, it should be all of them. So, guys, here's the thing. Here's how you can look at this table. Remember, the parallelogram is the parent to all of them below it. So, a rhombus, rectangle, and a square come from a parallelogram. So, if a parallelogram is checked off, they should be checked off for the other 3. All right. So, here for the diagonals, bisect each other is checked off for a parallelogram. So, it should be checked off for the other 3. All right. And remember, a square is a combination of rectangle and rhombus. So if it's checked off for a rectangle, it should be checked off for a square. If it's checked off for a rhombus, it should be checked off for a square. All right. The only thing you really need to know is the difference between a rectangle and a rhombus. All right. So you need to know the basics of a parallelogram and the difference between a rectangle and a rhombus. All right. Last thing, and then we'll take a break. So we're just going to do some true or false. All right. So this one comes from the hierarchy. So remember, the higher it is, if it's above, that means it shares the features with what's below it. All right. So in other words, rectangle will have all the features of a parallelogram. Square will have all the features of a parallelogram, but parallelograms do not necessarily have all the features of a square. All right. So we're going to do this in terms of thumbs up, thumbs down. Thumbs up for true, thumbs down for false. So all quadrilaterals are parallelograms. Thumbs up if that's true, thumbs up if that's, thumbs down if that's false. That is a big fat false. All right. Because trapezoids exist. Those are not considered parallelograms. Kites exist. Those are not considered parallelograms. And just generic quadrilaterals. All right. So that is false. Now, what about the opposite? All parallelograms are considered quadrilaterals. Is that true or false? That is very much true. A parallelogram is definitely a four-sided shape, no matter how you crack it. Crack an egg, guys. Get your head out of the gutter. Okay, so true or false? A thumbs up, thumbs down. A square is a parallelogram. Is that true or false? So every square is considered a parallelogram.
Yes.
That's most certainly true. Every square is a parallelogram. All right, think about this one carefully. If a parallelogram contains a right angle, it is automatically a square. True or false? Thumbs up, thumbs down. Yeah, it's false because rectangles exist. All right. So if it has a right angle, it's automatically a rectangle, but it's not automatically a square because we have not shown that the sides are congruent. Now, all rectangles are parallelograms. So every rectangle can be considered a parallelogram. True or false? That is very much true. Every rectangle you will ever come across is also a parallelogram. All rhombuses are squares. So every rhombus you will ever see is considered a square. That is definitely false. So even though all rhombuses have congruent sides, they don't necessarily have what? What's the difference between a rhombus and a square? Right angles. All right. Rhombuses have congruent sides like squares do, but they don't have those right angles necessarily. All right, they do, then it is a square. But rhombuses can be created without all congruent angles. All squares are rectangles. Is that true or false?
Yes.
Yes, every square is considered a rectangle. Every square is a rectangle. Because it has two pairs of opposite congruent sides and it has 9-degree angles. Nope. So, a parallelogram with 4 congruent sides will always be a square. Is that true or false?
True. False.
Thumbs up, thumbs down. Oh, it's definitely false. Because what exists? Rhombuses. Rhombuses also have congruent sides. So we cannot consider it a square until we know it has a what? A 90-degree angle. Last one, a parallelogram with perpendicular diagonals is automatically a rhombus. True or false? Thumbs up, thumbs down. What do you guys think? Yeah, that's definitely true. So, rhombus is the first subtype that has the perpendicular diagonals. Squares have them too, but remember, every square is a rhombus. So, guys, last thing I'll say before we go on break. That's why the hierarchy is important. Because if it's lower on the hierarchy, it has every property from the shape above it. All right? So, rhombus will have all the properties of a parallelogram, all the properties of a trapezoid, all the properties of a quadrilateral. A square will have all the properties of a rhombus, a rectangle, a parallelogram, a trapezoid, and a quadrilateral. A parallelogram will have all the properties of a trapezoid and a quadrilateral. The only one that doesn't kind of overlap is the kite. It has all the properties of a quadrilateral, but that's it. All right? So that's how you read the hierarchy. The lower it is, that means that all the shapes above it, it has those same properties. All right. So we're going to go ahead and take our 3-minute break. When we come back, we're going to start doing some proof stuff. So I'm going to set the timer for 3 minutes. Make sure you're back in this room by the time that timer goes off. What?
Okay, this is a hypothetical.
I don't think you meant it. I was just like, what? It's called a key that I need to print for myself. That I forgot to print.
I just usually trying to get it out. Yes. Yeah, but do you have any more? I have a lot. You make some. I'm gonna leave it up there. Make some. Yo, you like the dark food that you like this? Yeah. Yo, like I can't grab. This is actual like I would just leave it up here.
No, don't you.
That would it was so funny. But it was if you want for what purpose? That's pretty good.
Yeah, it's just energy. So then,
That's different one.
we got it down.
How'd you get it down? What I say, no way I'll reach it. Why did you seems like you're crushing it?
And then everyone's science class. It's like, you're able to jump up and like smack it.
That's not good. That's not fun.
All right, y'all. So after a little bit of thinking, I think what I'm going to do is we're going to finish up the last little bit of this page, and I'm going to call it a day. Let you work on that. All right, I promise. So we're just going to finish up the last little bit of this page because that'll kind of lead us into tomorrow, and then I'll call it for today because I don't really want to start proofs and not finish it because it's a whole thing. All right, so the last thing we're going to do is we're going to find the measures to these angles. All right. So the first one, number 18, it says that ABCD is a rectangle. So with a rectangle, that means that every vertex is a what? A 90-degree angle. So this angle's 90 degrees, this angle's 90 degrees, this angle's 90 degrees, and this angle's 90 degrees. Now, they gave us an angle already. So this tiny angle right here, they told us to be 24. Which angle would be the easiest for me to start with? What number? Number 6. So number 6, which is right here. All right. How would I find 6? 90 minus 24. And that would be what? Right, it'd be 66. So angle 6 is 66 degrees. I'm going to mark it on the picture because it may help me later. Now, let's talk diagonals real quick. What's true about a rectangle's diagonals? They're congruent, and they also do what? They bisect each other. So, since they're congruent and they bisect each other, isn't all four of these little pieces congruent? Yes. So, based off of that fact, which angle would be the next easiest to find? I would do 1. All right. Why would 1 be an effective angle to find? It's congruent to what? Nope. It's congruent to 24. Why?
Because their lines are congruent.
What is this? What type of triangle? Isosceles. What's true about an isosceles triangle? 2 of the angles are congruent, and it's the angles that are opposite the congruent sides. Well, is 1 opposite one of the congruent sides? Is 24 opposite one of the congruent sides? Yes, so they're congruent to each other. So 1 is 24. So if 1 is 24, what's 4 automatically? 66. Because that's to equal 90 degrees. So we're done. Now, which angle would be the next easiest to find? 3. I would say 3. Why 3? It's another isosceles triangle. So that means that 3 is congruent to which angle? 4. So it's 66 as well. What about the next angle? Which angle should I find next? We could do 5 or we could do 2. Which one do you want to do? All right, 2. What's easy to find about 2? Right. It's part of a triangle, and we got 2 of those angles of that triangle already. So we just add up 66 and 66, subtract it from 180. So what would that be? Be 48. So angle 2 is 48 degrees. Now, angle 5. What's this angle right here? If that's 66, this has to automatically be 24 because it has to add up to 90. And then that means angle 5 also has to be what? 24 because it's an isosceles triangle. All right. Now 7. How would I find angle 7? There's 2 ways. We could do 180 minus 48 because it's a linear pair right here. They're supplementary because it's on a straight line and they're adjacent. What's the other way I could do it? You could do the triangle sum theorem. So add up the 224, subtract it from 180, which 24 plus 24 is 48 anyway. All right. So what's 180 minus 48? 132. So guys, this is how you do these. They're just a big old puzzle. All right. You just kind of have to find a place that makes sense to start and then go from there. All right. Let's look at the next one. So this shape is a rhombus. So based off of what we know about a rhombus and its diagonals and its angles, which shape would be the most easiest to find? 10. Yeah, I would say 10 because what's true about 10? It's a right angle because they're perpendicular, so it's 90 degrees. What other angle is pretty easy to find? 9. Why 9? What do the diagonals do to the angles? They bisect them. So in other words, they do what? They split them in half. So if this angle's 36, that means this angle has to also be 36. Well, it'll be now 8 and 11 are both pretty easy to find because you just use triangle sum theorem, and they're actually going to be congruent to each other. Because remember, these 2 big angles are congruent, and since they bisect each other, they'll be congruent. Now, what's a good way to find angle 8? We can't do isosceles. We can make it into a triangle though, because don't we have the two angles right here? Because we know this is 90, that's 36. So we just add them up, subtract from 180. So what would that give me for angle 8? So guys, you have a calculator in front of you. Use it.
What did you say?
Add up 36 and 90, subtract that number from 180. It'd be what? It's 54. So since this angle's 90, this angle's 36, this one has to be 54 because it'll be the same thing. Yep, 54 and 54. All right, last one. This shape is a square. So it's a little bit of everything. So which angle's the easiest to find? Well, which one is definitely the easiest to find? 13 is definitely the easiest to find because it's a what? It's a right angle. Yep. So 13 is a right angle, so it's 90 degrees. Now, since a square has the same properties as a rhombus and a rectangle, that means that the diagonals are all congruent and the angles bisect each other. And since the angles are congruent, they should be the exact same bisection. What the heck? Hold on. Okay, long story short, the last two angles are 45. All right. Yeah, because the other two angles have to add up to 90, and since they're both isosceles triangles, they're both 45. All right, so for the rest of class, and you have 30 minutes, you can finish that delta math that I assigned yesterday. And if you finish that, there is some optional work that you can do as well, or you can start working on your definitions for your journal. All right. So I'll unblock Gemini that you can use for your definition for your journal. Now, if I catch you using Gemini to solve your delta maths, we're going to have a problem. All right. So
when is our next project?
whenever we get close to the end of this unit. So I'm going to say probably sometime next week. So you can either work on that delta math that I assigned yesterday, you can work on your journal definitions, or you can work on optional work. Pick something, but you need to be working on something. Also, hold on to those graphic organizers. We'll use them tomorrow.